Using the fundamental theorem of calculus, we're asked to find the value of the definite integral on the interval -1 to 1 of x to the fourth plus 3x plus 1. When we're looking at the area, we need to find the antiderivative of the function. So we're going to think of the power rule, which states you bring the exponent to the front and reduce the exponent by 1. Think of it backwards. 1/5 x to the fifth. If we brought that 5 out front, it would cross-cancel with this bottom denominator of 5, and the power would be reduced by 1, and that takes us back to x to the fourth. 3 x squared. The 2 would be brought to the front. It would cross-cancel with the denominator. Reduce the power by 1, and you're left with 3x. And plus x. 1 is a constant, so there had to be an x value after it. So that's where this comes from. So again, when we're finding area, we have to think of antiderivative, which is actually the original function. So now we have to evaluate this at our endpoints at -1 and 1. The fundamental theorem states that you take the antiderivative at point B minus the antiderivative at point A. Doing so, we're going to plug 1 in to our x values up here, and then we're going to subtract it with -1. So 1/5 times 1 to the fifth plus 3/2 times 1 squared plus 1 minus 1/5 times -1 to the fifth plus 3/2 times -1 squared minus 1. Simplifying, we end up with 1/5 plus 3/2 plus 1 minus, make sure we distribute this negative, -1/5 plus 3/2 minus 1. So we can simplify our like terms. We have 1 plus 1, that's going to give us a 2. We have a positive 3/2 and a negative 3/2, those will cancel. And then we have 1/5 plus 1/5 to give us 2/5. So then we're left with 2/5 plus 2. And we need to get a common denominator. So we rewrite the second fraction. We have 2/5 plus 10/5, and that's going to give us 12/5.